doing something very simple like connecting one end to a light bulb and then back to the other end. So you got a negative side and a positive side. And when you eventually hook up a second light bulb to it, it does the same thing. Although you may have noticed the light bulbs are not as bright then. Okay, which we can talk about a little bit later. So why do you suppose the light bulb went out if you broke the connection? So if you break the connection on one of these light bulbs, why does the other one go out? And that's because there's only one path. Which means if you break one of the paths, then the other one is also broken. Okay? It's like if you travel in like a national park that's just got like one big loop road. If there's buffalo on that road, not that this ever happened to me, you can't go anywhere, right? If there's buffalo on the road, you're not getting anywhere. You're stuck until the buffalo get out of the way. If this light bulb gets pulled out, this light bulb gets no energy because there's a break here in the circuit. Okay, and that is called a series circuit. It's where there's a single path for electrons to travel. Okay, and the way I can tell this is because there is only one way to go from the positive end to the negative, and that's by following this path. There is no other way to get there, and so that's how I know it's a series circuit. Okay, then you wanted to set something up where breaking one circuit would not break the other, and that would be something kind of like this. Okay, so the reason why this will work is because if I get rid of this one, the current can still get from one end of the battery to the other by going through this other branch. And if I break the first branch, I can still get from one end to the other. Man, my fingers are giant. I can still get from one end to the other by going on this other branch. So that is called a parallel circuit. And parallel circuits are where there's multiple paths. Your book defines it as devices are connected to two of the same points. So that's this here. This point and this point are the same for this light bulb and this light bulb. And so if you break one of the connections, the other connection is still there. That's the idea behind series circuits. Okay? And, yeah, what did you say? Yeah, so if you have two light bulbs in series, they're going to be dimmer. If you have two light bulbs in parallel, they're both going to be as bright as if they were only one lit by themselves. And the reason is they're both connected to the battery, and so they both get the full energy of the battery, which we'll talk about a little bit later. But they'll both get the full energy of the battery as opposed to only getting part of the energy of the battery. Good. All right, then I said explain what potential voltage is. We're mostly worried about voltage, but remember that potential difference and electric potential are pretty much the same thing as voltage. So first of all, it's the energy of circuit caused by the potential difference between 2 points, and that is measured in volts. Measured in volts, so make sure you have the unit there. And the purpose for this is basically this is the energy for the circuit. This is where the energy comes from. Circuits don't work without voltage. Without a voltage, nothing happens. It's like a flat pond. Nothing happens if the pond's flat. If you raise one, then it becomes a waterfall, and then things happen. Okay? But a flat pond, nothing happens on. Okay? And the part of the circuit that performed this task is the battery. And I wrote V because in the equations, V is a symbol for voltage. That shouldn't be surprising. This one will be current. So current is the flow of electric charge. It's measured in amperes. Usually we just call it amps. And the symbol in the equation is I, for whatever reason. The purpose of this is how the electrons move. And the part of the circuit that does this is the wires. All right, and last thing here we'll talk about with this lab is what is electrical resistance. So it's the opposition to the flow of charge. The symbol in the equation is R. That one shouldn't be surprising. This will be, the unit is ohms, and the symbol is the Greek letter omega. So if you're like, why is there a horseshoe in this problem? That's a hint that it's ohms for resistance. Okay. Otherwise, amperes is A and volts is V. So the purpose of this is it's to use the energy. What part of a circuit performs this task? That's the light bulb. Now, you may be saying to yourself,